today by going over the format first, okay? So we're going to take a look at the format of the test so we're all clear as tomorrow. And then we'll go into looking at the rest of the topics. So first, this is your cover sheet you're going to see tomorrow. The instructions are here, and I'll go through them, but the instructions the proctor is also going to read to you anyway, okay? But just so you know, this is the only time you're going to use the Scantron all year, and it's only for the multiple choice part 1. There's going to be 30 multiple choice questions, each worth 1 point each. And those are going to go on your Scantron sheet. Okay? 30 multiple choice, 1 point each. Similar to the multiple choice that you've seen in the past on tests. So that's a good reference to study from. Okay? Parts 2 and 3 are going to be answered on your answer booklet. Okay? There's breaks outside. Parts 2 and 3 are going to come from are going to be recorded on your answer booklet. And I'm going to show you what that looks like in a minute so you can see that. So the actual test itself, you're not going to write anything on at all. Okay? So again, you can write all over it, sure. Yeah, you can write on it. So part 1's that are multiple choice. If you want to do any scrap work, you can write all over the test. But again, the only thing that's going to be graded is the Scantron itself and then the answer booklet. It's not a blue book. Okay, it's an answer booklet that I've prepared, and I'll show you what it looks like in a second. So part 2 is going to be short answer. There are going to be 10 of those questions. And each of those are going to be worth 3 points. Okay, that's going to be another 30 points. So parts 1, which is multiple choice, and part 2 together are 60 points of your test. Now, part 3 is the free response, which is the mathematical-based problems. It's the same exact as your test, same format. So whatever you're used to is what you're going to see. There are going to be 8 questions. You're going to choose 5. Is that clear? Okay, so you're going to have 8 problems there. And you're going to choose 5 of them. So you would choose 5 of 8 in this section. You're to write omit on the 3 problems you want to exclude. Omit means I don't want to do that problem. If you don't write omit, I'm going to count the first 5 automatically. You need to write omit. Is that clear? So there's going to be 8 problems. It's in the directions 3 times actually. It's in these directions. It's on your test itself in the directions in that section. And it's on the answer booklet also in the directions. Okay, so you're going to see that over and over again, not to forget. Your proctor's also going to read that. So you're going to hear it 4 times actually. Okay, calculators are permitted. The exam must be completed in pencil only. Make sure, this is the next big thing, every single thing you do needs to be turned in. Okay, and I'm going to describe now, before I go into the actual answer booklet and what it looks like, what you're going to get. So, tomorrow when you walk in, your proctor is going to give you a packet or a bundle, and it's going to be paper clipped together. They're all paper clipped already. You're going to have a Scantron. You're going to have the test itself. So those are the first 2 things you're going to see. The Scantron you write your multiple choice on. The test itself you don't have to write anything on. You can use it as scrap paper. And that's where your scrap paper will come in. The third thing is going to be your answer booklet, where you're going to put your answers for part 2 and part 3. All of the work you want graded, anything that you want graded needs to go on the answer booklet. I'm not even going to look at your test. I'm telling you now. I'm not going to look at the test itself. I'm going to look at your answer booklet and your Scantron. That's it. The 4th thing is going to be your formula sheet. And the formula sheet is identical to the one that's on Moodle right now under documents and handouts. Okay? So there's going to be 4 documents. Scantron, test, answer booklet, formula sheet. I'm only going to look at the Scantron and the answer booklet. You need to turn back into the proctor every single thing I gave you with the paper clip around it in the same order you got it. And your proctor is going to tell you this, and I even instructed on their sheet to receive all the material in the way that it was distributed. Emmett.
For the answer booklet, do you just want the answer, or do you want us to turn it out?
All your work is going to be in there. And that's what I'm going to go into right now. I'm going to show you what it looks like. So, for the answer booklet, example, this is what the first page of your answer booklet is going to look like. So you're going to see short answer, which is like those 3, or on your test, they've been the 6-point problems. The ones that are conceptual, they're not really mathematical based. Most of them are things like, if the mass of this increases, what happens to the centripetal force? Or if the distance between object doubles, what happens? Or, like in the last test, 2 objects or 2 skaters push off each other. What was the momentum of the system immediately after? Those kinds of questions are your short answer. So you're going to see there were 3 points each. Up here is for me to keep track of your grades. This will be your multiple choice. This will be your short answer. And this will be your free response. So you don't have to write anything there. That's for me to write your grade. You're going to see your name slot is there, and it's going to be at the top of every page. Okay, the pages are front and back, so you're only going to see on the top of the front page. Please put your name on every page. It's so in case a page for some reason gets lost, I know it's your work. Okay, so that's what the first page looks like. You'll see 31, 32, 33, 34, 35. Okay, 35 should be on the next page. There's, I don't know why it's at the bottom of that one. Why is that? Oh no, there's 5 per page, sorry. The second page is 36, 37, 38, 39, 40. So those are the short answers.
The short answer is
10
the
questions.
10 you have to do. It's
You
not
do all
like
10, correct.
Okay.
So the short answer, you do all 10. Each are worth 3 points, totaling 30 points.
And those are the conceptual problems.
Mhm.
I feel
Yep,
like this
correct.
is a short test.
I would say if you were to estimate time, it would be the equivalent of 2 tests, an hour and a half. You have 2 hours though. So you're responsible for checking over your test completely. Okay, that's the equivalent in length. It would be about the same as 2 full tests. Is that clear? Okay, 2 full tests. You're allowed to leave after an hour and a half. Now, if you say you finish after an hour and 25 minutes, please don't leave at an hour and a half. Please take the other 35 minutes and check your answers over. Check your multiple choice. There are a lot of common mistakes. Okay, just like on your other tests, a lot of the multiple choice, the wrong answers are common errors. So don't jump the gun and don't say, A looks right, let me circle it. Read every single choice, please. Just like when you're doing this next part here, when it says choose 5 of 8, write omit on the 3 problems you wish to exclude, don't begin the first problem until you've read all 8. Read them all. Don't think, okay, the first one looks easy, let me start it, and then suddenly you're halfway through the first one and you don't know what to do. And then you did all this work and then you cross it all off and write omit. It's a waste of your time. Okay? Read all 8 problems and then choose the 3 you don't want to do. Okay? So you're going to see there's room for 2 per page here. So there's a lot of room here. 41 and 42 on the first page, etc. 43 and 44 until the end of the test. Okay? Any questions about the format? So again, it's about the length of 2 tests, hour and a half. Now, for all of your exams, you can leave after an hour and a half. But within the last 15 minutes of the test, you cannot leave early. So if you finish after an hour and 45 minutes, don't give your proctor a hard time and say, I'm done, I want to go. Okay, if you're done at the hour and a half mark, you can go. I don't know if that's new. I'm new also, so I don't know if it was the same. But has it been like that? Okay. I know. Maybe it depends on your I know that I'm proctoring tests, and I'm going to follow the rules that were given to me. Okay.
No, Coach A.
So
Yeah, Coach A.
Gives you answers.
after an hour and a half, I hope he doesn't, because I hope you're not going to be right in the physics test. That's for sure. I'm not trying to be mean, but for real. After an hour and a half,
Multiple choice.
it'd be like me trying to give answers to like social studies test on history that I don't know half those
My
answers
English
to.
test, Coach A was like pointing to multiple choice. I was like,
So
Freshman year, we
Anyway.
my bio diagram.
after an hour and a half, again, you can leave if you're done. But if you're not done after the hour and a half, you're not going to be able to leave early because then it gets too many people moving around toward the end of the test and everybody's anxious.
I really hope you're not
Okay.
proctoring any of my tests, because that would drive me crazy if I have to sit there for the rest of the test.
Well, either way,
I leave
check
at
it
the
over.
1:30 at the
Check it
one,
over.
an hour and 30 mark, even if I'm not done.
I would not. I would not leave at that point, guys. Okay?
Whoa,
Hello?
No, it's my alarm. Relax, guys.
Sure, gotta text back your alarm.
Or shut it off. Now, make sure you check over your work, okay? Please don't just say, I want to go, it's an hour and a half, I'm going to go and I haven't checked anything. Check it over. Don't waste that time, or don't think you're wasting your time because you're not. Okay? Any questions at all? I'm going to go on to review.
Are you just gonna have for the 8 problems at the end? Is it just gonna be like one problem?
It's going to be 8 problems. It's literally 8 problems on one sheet of paper you're going to see, and you choose 5 of them.
Alright.
No, I know that. I'm just asking about like what they're on. Is it gonna be like each topic, or is it gonna be like?
Yeah. So it's like, there'll probably be like a projectile motion or 2, inclined plane problem, energy method problem, momentum problem, circular motion problem. Those are the major topics we did, so there'll probably be 2 of some of them, yeah. But it'll be evenly distributed, just like the rest of the test will
Okay,
be.
so it's not like what we just learned. That's not more.
Nothing is more emphasized than anything else. It's about the time we spend. So, for example, projectile motion was really chapters 2 and 3. It was 1D motion and then projectiles in 3. So you'll have at least one of each of those for sure. Energy methods, which is a whole chapter. Most of energy method was either work, Or the other part was energy balance, like mechanical energy being potential and kinetic. So there'll probably be one of each of those. There'll be a problem on forces. There'll be a problem on inclined plane and forces. There'll be a centripetal circular motion. There'll be a momentum problem. So yeah, it'll be evenly distributed. Okay? You obviously have all been studying, so study the way you've been. Your problem sets, your old tests, your old labs, your notes. But if there was anything that you were to study tonight and I were to give you a suggestion, it would be your old tests. Okay? If you were to spend tonight studying, even if it's like an hour, use your old test tonight as the last thing. Please don't spend like 8 hours tonight studying. It's not going to help you at this point. Okay? I'm not trying to be mean, but I'm being honest. It's just going to make you more stressed out. And you're going to come in tomorrow and looking like a zombie and not being like, oh, I don't know what to do. Okay? So if you're going to study tonight, max 2-3 hours at most for physics tonight. Okay? And then space out your other studying over the weekend for your other tests. Don't study until the wee hours of the night and then you're like, oh, I don't know what to do.
I'm not allowed to study tonight.
Okay? No, I didn't say that. Okay, but if you're going to study anything and you specifically want to study for an hour or two tonight, I would recommend studying your old tests. Steph?
What if we haven't, hypothetically speaking, we haven't necessarily began studying for the midterm specifically?
Yeah.
What would you study if you hadn't begun yet?
Where would you
Your old
begin?
tests.
Where would you begin?
So,
at
one
the same
and
time?
whatever we just
1 through
did.
6.
Wait, do you have the solutions to the test? I didn't know that.
Documents and handouts. They've been there all year.
Choice.
You are so professional.
We're gonna go over all the topics that are left. Yep.
The multiple choice. Do you recommend we study the multiple choice on the test?
Yeah.
Yeah.
Is that it? Is that the only stuff I've studied for multiple choice?
If you're studying tonight, that's what
If
you should.
I only study my old test, am I done?
Tonight, you'll do all right. You would have done better had you studied previously, surely.
I did study.
If Mr.
Then you'll be
Brennan
fine.
and Miss Brown didn't give us 1,800 projects,
Oh my god, I spent 4 hours at a
Wait.
zone.
Are you giving us
I don't
for
know.
extra
I just
credit?
finished.
Is that you who said that?
There's no extra credit on the
That's a
midterm.
horrible problem for extra credit. Sam.
No.
Any questions?
Alright, I want to start reviewing.
All right, let's start.
Little extra credit shenanigans.
Okay. The free body diagram.
That's what I'm going to start with.
FBD.
FBDs, yep. And we're going to do, that's exactly what we're going to do. We're going to do FBD on an inclined plane. Okay?
Can you re-explain the boxes because I forgot how you...
Like the actual, like arrows and stuff. Yeah. All right. So, let's look at a problem that says the following.
Riddle the next page.
An object is on an inclined plane. That's one word. Oops.
It is hot in here. It is.
Oh, I'm so cold by the window.
You guys can swap seats. Swap seats if you're cold.
Close the window.
Can
No, open it a little. It is a little warm. Just swap seats with somebody. It's fine.
There looks like nobody else. Helen, you want to swap seats?
No, I don't want
Some of y'all want to swap seats?
There's also a third row that hasn't been taken over here. You can just. Lova can move up a little. We can move that
I
desk.
can't see very far back. I can't really see.
Yeah, I'm
Can we
literally
shut
blind
this
as
light
bad.
off? It's like literally piercing me. Oh, thank you.
Better? An object is on an inclined plane and at rest.
Coach A said those lights are really bad for your eyes. They're fluorescent.
The angle
I know. You always said that. Coach A is God.
The angle of incline is 45 degrees.
I don't know who's. I honestly never looked at
Determine the coefficient
the mu value.
good, of static friction. Okay? Determine the coefficient of static friction.
Well, I'm just gonna scooch right in here. Just
Maneuver.
Steph, you could sit over here if it's really warm for you. That's fine. Emmett,
Okay, this is what I decided.
Heat static, is that like from
90 minus theta over sine 90 minus theta. Yep, that'll be our final answer. Okay, but if this is like a part 3 or a free response, you should go through all the work of it, and I'm going to do that now to show you.
Okay.
And this will maybe go through some of the free body diagram questions. All right.
No.
Good. Now, we start these problems by thinking about a diagram first, okay? An inclined plane looks like the following with an object at rest. Now, we have to think about the forces that are acting on this object. There's no applied force anywhere, okay, so we don't have to worry about that. So they're all the forces that are inherently there. Give me one of them. Give me one of them. Erica.
FG.
Good. Force of gravity acts straight down.
Wait, isn't FG X and FG Y?
We're going to break it up.
That's like that?
Yep.
Sorry, I just forgot.
Another force that's acting on this. Charles. Fn. The normal force. Always acts on an object when it's resting on a plane. Now remember, and this was one of your multiple choice on your tests, and a lot of people got this wrong, the normal force is always perpendicular to the plane. So if the normal force is on this desk, it's straight up. If it's on an inclined desk, it's out at an angle, like it was showing it here. The common mistakes for that multiple choice were things like the normal force is always equal and opposite the weight. That is not true. That only happens when it's a flat surface and there's no other force acting on it, like right now with this water bottle. But the minute I start lifting up, the minute I tilt this desk, it is no longer equal and opposite the weight. Okay? So that was the common mistake on that test. I think that was test 3.
It's always perpendicular.
Okay, or no, test 4 maybe, test 4. Always perpendicular to the plane. There's one other thing acting on this that's holding it there.
Friction.
Friction. Okay, friction is acting on this and it's holding it there.
F squared.
FG is always just down from the center.
Correct. Now, for these types of problems, and if you remember, this was the example that I made that long video that you guys watched during Hurricane Sandy.
Which was the most confusing
Okay.
thing I've ever seen in my life.
And then he farted. He's distracted for us.
We tilted our axes. I still don't remember that. Like, I would admit that easily. I have no problem saying that.
It's literally like.
I think my phone went off in the video with a text message and she interpreted it that way.
Does your phone sound like?
I don't know what Helen was thinking about, but... So, in the video, we talked about how we tilt our axes for these kinds of problems. And the reason we do that, I discussed already, but I'll discuss again. What you'll notice is this. The normal force now acts right along the y-axis, and the force of friction acts along our x-axis now. And that helps us, because we don't have to worry about breaking that into components. But this is where we break Fg into components. And this is what Helen was mentioning a minute ago. What we do is we break that into its components, and it looks like the following. We take Fg, and we draw part of it acting in the y direction, and part of it acting in the x direction. And we call this Fgx, and we call this Fgy. And once we've done that, we no longer need to worry about this Fg. Okay, so we can get rid of the Fg that we see here.
Wait, I really think why.
We do that so that it acts along the axis, or else we can't use our equations of motion. Remember, our equations of motion say the following. The sum of the forces in the x direction equal max, and the sum of the forces in the y direction equals may. If we didn't have everything acting along those directionals, we could not use this equation. Okay? Now, the easiest way to do these problems is to literally list what is going on. So we look in the x direction. In the negative x direction, we see that the force of friction acts in this negative x direction. In the positive x direction, Fgx acts down. So what we write is that we have a negative force of friction and we have a positive Fgx. And I'm going to leave this blank for a second on the right-hand side. In the y direction, we have a negative Fgy now and a positive normal force acting up. Erica?
Is it negative because it's going against friction?
No. Fgy?
Yeah.
Fgy is negative because we drew our positive axis upward. Look at the y. See right here? This is the positive y direction.
Oh, so
This is the
right.
positive. Remember, tilt your head to the right. Like this, Erica. Tilt your head this way, and that's what we're looking at. Okay?
Okay.
So we've got a positive Fn acting up and a negative Fgy acting down. Now, max and may is the mass times the acceleration. Is this object moving at all?
No.
Is not moving anywhere. So is there any acceleration at all?
No.
So both of these become 0.
Wait, which one's acceleration times?
They are both, but one of them is the acceleration along the x-axis, one is the acceleration along the y-axis. Listen, there will never be acceleration along the y-axis for these problems, because then it means the object will be floating. If there was acceleration, the object would have to slide up like this, right? Accelerating up and be floating off the axis, which is not physically possible. So you're never going to have may. This term is always going to drop off, but this one might not always drop off. If a problem were given to you and it said the object is not, instead of saying it's at rest, if it said the object is sliding down the ramp with an acceleration of 2 meters per second squared, then you have a 2 right here for our x, and you're going to have m times 2. Is that clear? Again, this can have a value if there is acceleration down the ramp. But because it's at rest, there is no value. Now, notice, the mass was not given to you in this problem. So what do you expect might happen throughout the process, Nicole?
They'll get canceled out.
Yeah, the masses are most likely going to cancel. Now, this is why this kind of a problem is a little bit trickier, because you can't really plug numbers in anywhere. The only number you have is 45 degrees. You don't have anything else, actually. But what we do know, and we know from either our formula sheet or we know from remembering it, is that we can replace FF. Who remembers? Anybody remember the definition of FF?
It equals FN.
Not FN.
Oh, F.
Mu FN.
No,
Mu FN. Mu FN. Try and raise your hand. Good answer, but try and raise your hand. Mu FN. Now, it's mu static because the object is stationary. Next. Emmett, do you remember? How do we break up the components of the force of gravity on an inclined plane?
You do mg times the cosine of 90 minus theta.
Very good, sir. Cosine of 90 minus theta.
Just call him sir.
I always address people as sir. You haven't realized that by now?
It's his bow tie.
You've never heard that? Listen more carefully. I do it a lot.
I don't think.
Wait, what do you say?
Mu s, mu static. Remember that's what we're solving for?
Just trying to start.
Okay? We're trying to solve for the coefficient of static friction. And that's what mu s is. Now, Emmett remembered that whenever you're looking for the x component, it's always cosine. But on an inclined plane, it's the cosine of not theta, 90 minus theta. In this case, it doesn't matter, it turns out. Because if I use theta, it'd be 45. And 90 minus 45 is still 45. We just happen to be lucky there. I'll tell you now, it's not going to be 45 on your test. It'll be maybe 30 or 60. Okay? I know, I'm just so mean. So, remember that Fg is always mg. That's where that comes from. So Fg, this portion right here is mg. And because we're looking in the x component, we put the cosine. So over here, I have Fg, which will still be mg, but I want the y component.
Wait, Fg is only equal to mg when there's no other force acting on?
When it's straight up and down, when it's not an inclined plane. Okay? Fg is mg when it's not an inclined plane. So that's my x direction equation. Okay, it kind of ran over into the y direction there. I'm going to write the y direction below it in green. In the y direction, I don't know Fn still, so I'm going to leave that alone. But I do know how to write Fgy. How do I write Fgy?
But don't we also know that they're equal to each other?
No, they're not. Again, they're not.
FGY.
Fgy is sure.
That's what I'm saying.
But let's write our equation first.
Ng sine 90 minus.
Very good. Now, this is clear evidence that Fn is not always equal to the weight. Because if I simply move this over, we're going to see that, as Helen just said, Fn is equal to the weight, but times the sine of 90 minus theta. Okay? So again, an object at rest on a flat surface, you would not have this sign here anymore. and you would end up getting Fn equals mg. Again, this would not exist if we're on a flat surface. So it would just look like Fn and mg, and then they would be equal and opposite. But because it's on an inclined plane, we have to think about components. Now, what was the goal of the whole problem? What are we trying to figure out? Everybody. Mu. Look at your equation here. I know g, 9.81. I know theta, 45. I don't know Fn though. So what can I do in this equation?
Why is G not negative 9.81?
Because we are already taking into account the negative sign next to g. It's going down the plane, and that's in the positive x, so we have the positive there. And here, there's already a negative sign here for this component of g. And you also need to remember that we talked about in class, g is only negative when we're talking about projectile motion. Okay? Emmett, what can I do in this equation here?
Since that whole thing equals 0, you can just move the mg sine 90 minus theta over the other sides.
Good job. Very good. So let's go ahead and do that. So this becomes Fn equals mg sine 90 minus theta. Okay? Remember to put parentheses around your 90 minus theta, because if you type in your calculator without it, it's not going to come out right. The calculator, I think, automatically puts an open parentheses, okay? But just make sure you do that. Now, I'm going to take this expression here and plug it in right up there. And I'm going to write the new equation in blue. So I'm taking the y direction and using Fn, which is my linking variable, to plug into the x direction, just like time was the linking variable in projectiles. So we have negative mu s times Fn, which is mg sine 90 minus theta, plus mg cos 90 minus theta equals 0. So again, just so we're all clear, we've taken this expression and plugged it in right up here. Then we take this equation and rewrite it down here. And now what we'll notice is that we can move part of this over to the other side, and our m's are going to cancel. Our g's are actually going to cancel also. So this problem turns out to only be a function of theta as a solution, and that's what Emmett asked in the beginning. Steph?
Is there a way on the midterm to avoid a problem like this?
Well, it's one of your 8, so if you want to omit it, you can omit it. But, there might be 2 inclined plane problems, and then that's using 2 of your omissions right there.
I think that's
So,
kind of my tool mission.
You know what I'm saying?
Yeah. I think I'm good about that.
Depends on what you're good at. Some people are better at this than others.
Oh, wait, the reason why I did Fn equals mg,
This isn't my,
you're trying to find Fn on that side, so that's why you did it. That's why you equaled it to that?
Yeah, because here we want to find mu s. Remember, this is the goal. And we can't find mu s because this is unknown. So if I can determine what this is right here, and then plug it in, now it's a lot easier. Okay?
My phone is calculator.
There's no calculator needed for this.
You were trying to find Fn,
Yeah.
you didn't do that?
You can do it. I'll show you how to do it in the end.
If my
I didn't hear what you said.
No.
Okay. All right. Let's continue. I'm going to move this entire part over by adding it.
Oh, and then you divide by everything.
Good.
Got it. Static.
Now notice mg is on both sides, so divide by mg on both sides. Those drop off.
Is this always the way that works? I'm going to admit this.
Okay. Now, keep in mind though, if there were acceleration, this would not be a 0 anymore. Okay, and I'm going to show you how come that is. Take a look back up here.
I'm confused.
Okay, remember up here where we had a 0? Oops.
Just moved it over to the other side.
Remember up here where we had max went to 0?
Yeah.
That was because there was no acceleration. Had there been acceleration down the ramp, say the acceleration were 3 meters per second squared, this would be 3m.
Can we do one with acceleration?
Okay? I'm literally going to show you right now. You would just write 3m right here. It's the same exact problem. That's what I'm saying. This would be 3m, which would make this a 3m, which would make this a 3m. And there would still be m in all the equations, so m would still cancel. That's the whole beauty of these problems. Okay? this would still have a 3m now, and the m could drop off in all spots. G would not drop off though, that's the only thing that would be different. But you know G, 9.81. So that part doesn't really matter for G.
Negative in this?
You would not, no. Only projectiles.
Projectile alone.
One sec. The last thing is divide by sine on both sides.
Sine 90 minus theta.
Correct? And that's your generic solution. And notice, all you need is theta to get the answer from US. Okay? The answer from US in this case will be 1. Because the cosine of 45 is the square root of 2 over 2. And the sine of 45 is square root of 2 over 2. Okay? So the final answer would be 1 in this case. Yep? Just so in case you're checking numbers. Check your calculator. It must be in degree mode. If it's not in degree mode, you're not going to get an answer of 1. Cosine of 45 is 0.7071. Sine of 45 is 0.7071. Those just cancel out. You end up getting 1 for this problem. Okay, Chelsea.
Can you just remember that like the formula is like for mu, or like mu?
You can try to, but if the problem changes and there's acceleration now, this would be MA. There would be, let me do this in my head real quick. There'd be a positive MA over here. The M's would still cancel, but there would still be G's now. And there would be a positive A in the denominator. So if there were acceleration, that would be the new answer. I don't like to memorize things personally because it's too much work. Okay, you don't want to have to memorize all this. And remember, guys, you cannot put things in your calculator. The proctor is going to come around and clear your memory. Make sure there's nothing in there. If there's anything in there, you're going to automatically get a 0. Do not come in with a calculator with something in the memory. And make sure, if you want to check, I can show you after class, or in between the break, I can show you. But remember, everybody in the entire school is taking science at the same time. You can't borrow a calculator tomorrow. You have to have your own. Same thing with Tuesday for math. Every grade level is taking the test at the same time, and every grade is using a calculator. Don't rely on someone else, and do not come to the math science office. We already have been told not to give out calculators. It's not fair if there are 4 people, or if there are 4 of us or 5 of us in there, and 30 people come for calculators. You need to have your own. Miss Sarusi is so nice. I don't know how she's managing, but she has batteries if you need them, and they're only 50 cents each, which is so much cheaper than you'll get at the store. In the store for 4 batteries, it's like $8. She's selling them for 4 for $2, okay? She's a battery dealer? She gets them on the black market. No. I think what she's doing is she's going tonight to like a Costco or a BJ's and getting a sleeve of them where they're only like 50 cents each anyway. BJ's wholesale or Costco wholesale, they're like 50 cents each for batteries. Okay? Yeah, in Rye, I'm guessing, or somewhere up there, right?
Fresh acid.
Okay. Anyhow, again, guys, look.
Why are you so mean?
This is the answer if there had been acceleration in the problem. If there was no acceleration in the problem, you go back to what we just had. Watch, if the acceleration was 0, this drops off and the G's cancel. And that's what we just had a second ago. Okay? Now, follow-up question for you. If the problem stated that the object was sliding down the ramp at a constant velocity means 0 acceleration. So if the problem had been constant velocity instead of being at rest, it's the same solution we have here. It's identical because acceleration is 0 when there is constant velocity.
Give us an acceleration.
Don't know. You have to wait till March C. It's the same solution though.
No suspense.
Same solution either way. Okay, Emmett, you had a question at one point. Did I answer it or do you want to ask it still? Okay. All right. Let's look at an example of a problem where we have a free body diagram again, but with work involved. Okay?
Draw some F-Y.
You just came to that.
Yeah.
If a force is applied to an object with a mass of 5 kilograms, and the force's value is 30 newtons, while the force of friction is 20 newtons, determine, I should say, if a force is applied horizontally, sorry, at the top, change that. Determine, part A, the acceleration, part B,
You're not preparing us for
the acceleration if, what's wrong?
these run-on sentences.
The acceleration if
You're really throwing out my group for English.
the applied force
You threw out the group.
is now at, let's see, what's the angle I want to use? 5 degrees. I picked the number for a reason then, that's why.
5 degrees?
5 degrees. 5 degrees above the horizontal. Take a 2-minute break, guys. Take a 2-minute break. Come back when the bell rings, please. 5 degrees above the horizontal.
Do you have any more snacks?
No, I might go with that.
If anybody wants me to look at their calculator to make sure there's no programs or any questions, ask me now, please, during the break. All right, so for this problem, as all the others, we're going to start with a free body diagram. Okay? So we have a force applied horizontally. We have the force of friction acting in the negative direction. We're given a mass. Okay, so we can draw our free body. Let's go ahead and do that. Now, the force that's applied, we're going to draw it to the right. And the force that's applied has a value of 30 newtons. The force of friction acts against motion always. So the force of friction is a value of 20 newtons. We know that this object has some sort of a mass, so there must be gravity acting down, and there also must be the normal force acting up.
So every time it says, if it says like the mass is 28, you write FG is 28 kilograms?
Well, that's the mass. Fg is mg, so it'd be 28 times 9.81. Okay? So, for this problem, we are told, or we are asked to determine the acceleration of the object. Now, the acceleration is going to occur in which direction? In the positive y or in the positive x?
Positive. Wait, what? Positive x or y?
Yes. Where is this object going to move? Is it going to move horizontally or is it going to move vertically? Emmett.
Horizontally,
How come, Emmett?
because it's not just going to float off the ground.
Exactly. The simple reason it's not going to float off the ground. What else? Look at the forces. Isn't 30 more than 20? Right? So the force that I'm pulling on this with is more than the force of friction acting against the object. Okay? So we want to remember Newton's second law says F equals ma. But what is this F really? That's the key. This F is the overall force. So if I've got 30 to the right and 20 to the left, I have to write those out. So let's go ahead and write that. So we're looking in the X. Now, what we're going to see is that we have FP... Helen, stop it. Come on. We have FP to the right. We have FF to the left. So for this kind of a problem, we're not even really looking in the y direction yet. And it turns out for this problem, we don't need to use the y direction. And the reason is because we're given FF. FF is given as 20. Had we not been given FF, say we had been given mu k, the value of kinetic friction, the coefficient, we would have to do mu k times Fn to get FF. But in this problem, we are given FF, we are given FP, we are given the mass, we can simply find A. But again, had we not been given FF, had we just been given mu k, we'd have to do mu k times Fn, and we would get Fn from the y direction.
Wait,
Just like we did last time. Erica first, go ahead.
Oh no, you just answered my question.
Okay, Sibyl.
Wait, UK times what?
We don't need it, but remember that FF equals mu Fn. Depending on if it's moving or not, it's either K or S. If it's moving, it's mu K for kinetic. If it's not moving, it's mu S for static. Okay? So again, had we not been given FF as negative 20, we would have to figure out Fn from the y direction and multiply it to get FF. But we know these values, so let's plug them in. What was the mass I gave? 5?
No, you didn't.
No?
5 kilograms.
5 kg.
Okay, so the numbers work out easily. A is going to be 2. Okay, A is 2. What are the units? Meters per second squared. Units, 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 units. Remind me after this problem, what I'm going to do is go over all the different variables we've had this year and what the units are. Okay, so we're all clear after this problem. Now, part B. Let's take a look at part B and see how this changes. Part B is the exact same problem, but now this applied force, FP, is at an angle of 5 degrees above, like this. So what I'm going to do is go through the answer key that way. So let's take a look now for part B. We draw a free body diagram again, but now this is at a little bit of an angle here. And I'm going to exaggerate it obviously so we can see, but the angle is now 5 degrees. It's still a force of 30 newtons, and this is still a force of friction of 20 newtons. Okay? Now, FP acts at an angle. Therefore, we have to think about the fact that there's FPX and FPY, just like we had FGX and FGY with the inclined plane. Okay, FPY and FPX. X is along the horizontal, Y is along the vertical. And remember that if you want the Y component, you use sine. If you want the X component, you use cosine. So FPX is simply 30 newtons, which is our force given, times the cosine of 5 degrees. FPY is 30 newtons, times the sine of 5 degrees.
What equation is this?
This is just remembering our vectors that we went over, where x represents cosine and y represents sine. Okay, always. So you take whatever you had, which was 30 newtons, you put it up here, and you multiply it by the correct trigonometric ratio. Okay?
It's 20, FPX is 29.88.
Okay, and what we'll notice, and that's what I was going to ask, FPX goes down only a little bit. What is it, 29.88?
89 maybe.
29.89. It slightly changes it, but only by a very little bit. And that makes sense. The reason it only slightly changes it is because that angle is so small. If you had changed that angle a lot, it would reduce the x component a lot more. So what we'll end up getting now, for our equation in the x direction, we have sum of the forces in the x direction equals MAX. So we're going to have FPX minus FF equals MAX. FPX, Erica said, was 29.89 minus 20 equals 5 times AX. So what's going to happen is our answer is not going to be 2 anymore. It's going to be a little less than 2. Okay, our acceleration is no longer just going to be 2, but it's going to go down a little bit. And that makes sense. It's as if you were taking an object. If I wanted to move this garbage can as fast as I can horizontally, I should get down to the level of the garbage can and pull. But if I pull at an angle, it's not going to pull it as much. Okay? So the first one is going to move quicker than the second one. So what do you end up getting? What's 9.89 over 5? Emmett?
1.9772.
Thank you. 1.977. And we're going to keep those decimals just to emphasize the fact that it went down. Again, when it was horizontal, the acceleration was 2. Now that it's not only horizontal, it's gone down a little bit. As this angle theta increases, this value will go down. And you could try it. Try instead of cosine of 5, try the cosine of something like 30. Okay? It's going to become 0.866. around 20, this will become around 25 now, which would make this answer around 1. Okay, so as theta increases, this quantity goes down, causing this quantity to go down further. Okay? Now,
What about the y direction?
what about the y direction? The y direction would only be useful in this problem if we weren't given ff. If we were given mu, then we'd have to do mu fn to get ff. But we were given ff in this problem.
So what was the point of getting FUI as opposed to...
Just to show that it's breaking into components, yeah. But we never calculated that, notice? We didn't even calculate that number at all. Alright, before I go on, I still want to do work and then energy balance. At least those two more topics still. We want to do first units. Okay? So I'm going to write down the name of the variable. I'm going to write down when it's used and then the units of each one. Okay, Helen?
I mean, is there always only going to be two forces in one direction?
There could be more, but yeah, we've only done it with
Always
two.
only going to be two, right?
Yeah.
Alright.
Okay? Alright. First unit that we started with this whole year. First unit was displacement.
That was my favorite.
Okay, and this has the same units as distance. So I'm going to put them together here. And their units are meters. Okay? Meter. I'm going to put the abbreviation and then the actual unit. Second thing we went through. When we had displacement, we also had time. And time was measured in seconds. When we took displacement over time, we got velocity. And we took distance over time, we got speed. And those units were meters per second. We also then looked at mass when we went to Newton's laws. And mass was given in kilograms. This was the only unit that had a prefix normally next to it. Everything else is normally by itself. There's no kilo in front of meter. There's no micro in front of second. But there is kilo in front of gram. That was pretty much chapters 2, 3, and 4, without the last part, which was force. And force, if we remember, is measured in newtons. And that's capitalized, by the way, if you write it out. Okay, that's chapters 2, 3, and 4 as far as variables and units go. Okay? Now, there was one other thing in these chapters that didn't have units. Mu. Mu has no units, but mu measures the coefficient of friction. I'm going to pause with our units for a second to discuss mu a little further. But there are no units on mu. In case you're wondering why, here's why. Side note. FF equals mu Fn. So if you solve for mu, you get FF over Fn, right? But FF is measured in newtons. Fn is measured in newtons. Newtons over newtons cancel, leaving mu to be unitless. Okay, it is a ratio. Tell me, somebody raise their hand, please. Physically, what is mu? What is mu? And this is something that's difficult sometimes for students. They know where it comes to play, but what is it? What does it describe? Sibylla.
The friction is between two objects.
Very good. It's the surfaces, really. Okay? It's the composition of the surfaces. If I have ice and metal, such as an ice skater, mu is very low. It is almost frictionless. It is close to zero. Can mu be negative?
No.
No, mu cannot be negative. So you might want to write that one down. Mu cannot be negative. It can go as low as 0, and the closest thing you're going to get is something called Teflon. Good memory, ladies. Teflon. Okay? Now, an example of a high mu value would be something like sandpaper on concrete. Try and rub sandpaper along concrete. You're going to feel a good deal of resistance because that surface is very rough. There are a lot of microscopic abrasions there, okay? They're rubbing back and forth. There's a lot of peaks and valleys that are breaking off each other. So mu is really the composition of the two surfaces in contact. Now, to follow up with this, and this was something else we stated. We have mu-s and we have mu-k. S stands for, everybody?
Static.
K?
Kinetic.
Now, static means stationary, kinetic means moving. It is more difficult for me to start pushing this desk than it is to keep it moving. With that statement said, what can you tell me about the relative values, Emmett, of these two coefficients?
US is greater than or equal to mu.
Well done. Okay, mu-s will always be greater than or equal to mu-k. It is tougher to break static friction and to get an object moving than it is to keep it moving. Okay, it is easy to keep something moving.
Tougher to break an object. Static what?
Static friction force than it is to overcome the kinetic friction force. So, if you check on your test, there was an example I gave you in one of the multiple choice. You were told the value of mu-k, and it said, which of the following may be a value of mu-s? It's got to be something bigger, right? It's got to be something bigger. Mu-s will be bigger than mu-k, or equal to. Greater than or equal to. All right, let's continue with our units now, or our variables. So that was chapters 2, 3, and 4. Chapter 5 was energy. We had work. Okay? And these are all the same units, so I'm going to lump them together. Potential energy and kinetic energy. All of these have units of joules. Okay, units of joules. And just so you remember, a joule was a Newton times a meter. Okay? It was a Newton times a meter.
Is that going to be like multiple choice questions?
No, but you need to these are good to know because in a problem, your units indicate to you what's going on. By the way, I did forget one thing. Sorry, I apologize. Up here, we did displacement, time, and velocity, and we didn't do acceleration. So let me just reiterate that. Okay? Acceleration, good, is given as meters per second squared. Okay? Meters per second times second. That's what second squared means, okay? Meters per second per second. Acceleration, meters per second squared. A lot of you wrote meters per second for centripetal acceleration on your last test. And you lost a half a point. Please don't do it again. Now, let's continue with this. So, chapter 5 was work and energy, and it was all measured in joules. In joules. Chapter 6 was momentum. Momentum, remember, is mass times velocity. The units are just whatever mass is times whatever velocity is. Mass is kilograms. This is momentum. And it's meters per second.
Is
Good.
momentum the little p or the big p?
Little p. Oh, big P we didn't go. Good. Good thing you brought that up. Power. Let's jump back and do power also. Power was big P, and power, watts. Remember,
And capital W.
capital W for watts. And remember that watts is really a joule per second. It's a rate of energy transfer. Power is the rate at which energy is transferred, or the rate at which work is done. Power is the rate at which work is done,
Joules per second.
which is known as a watt. Very good. Joules per second. So back to chapter 6. Momentum. Just remember that momentum is mass times velocity. Kilogram times meter per second. All right. Next, we had centripetal force and centripetal acceleration. Same units as force and acceleration. Okay, centripetal force is still newtons. Centripetal acceleration is meters per second squared. This was the third to last problem on your last test. Okay? Finally, the last formula that we went over was the force of gravity. Gm1 m2 over r squared. It's a force. It's still newtons. It's still newtons. Okay? All right. I'd like to do an example of work and an example of energy balance. And we can do work and power at the same time, because we can just give a time and find the power. An object is pulled
Bless you.
at an angle of 60 degrees
I have Tylenol if you want.
with a force, I'm good, thank you ladies,
Oh, I won't.
of 30 newtons. If the displacement is 10 meters over a time period of 5 seconds, find A, the work done by the force, and B, the power generated. Okay, so an object is pulled at an angle of 60 degrees with a force of 30 newtons. If the displacement is 10 meters over a time period of 5 seconds, find the work done by the force and the power generated. Equations. Chelsea, part A.
For work, it's F cosine theta times the absolute value of x.
Good job. Okay? Work is F cos theta times the absolute value of x. What about the equation for power? What is power's definition? Just think about it that way to make it easier.
Is it power equals force times time?
No, force divided by.
That is
Work over time.
force times velocity is power. That's one of them. But we don't have force, we don't have velocity here. We kind of do, but we don't.
Work divided by time, right?
It's work over time. Okay, work over time. Remember, power's definition is the rate at which work is done. A rate always means it's over time. Rate is always over time. Okay? If I said the rate at which I walk across the room, that's my speed. It's distance over time. Okay? So these are the formulas we're going to use. Part A. The force is given as 30. The angle is given
60.
as 60. Thank you. And what is the absolute value of 10? Simply 10. Okay? So we're going to end up getting here is 150 for our work. And what are our units here, folks? Good, joules. Because we're looking at work. Make sure you check these numbers. Cosine of 60 is 1/2. If your calculator is not in degree mode, you're not going to get the right answer here. If you got an answer that was not 150, then you better check your mode and make sure it's in degree mode, not radian mode.
Cosine.
Okay, cosine of 60. And that should be 0.5. If we want the power generated, you don't get it? So then go to mode and make sure you're in degree. It probably highlighted radian, right? Go over to degree.
How do I select it?
Enter on degree.
And that's it? I don't have to change anything else?
Nope. To find the power generated, take the work done over the time period.
I still don't have 30.
But you have to multiply all the numbers.
No, for cosine of 50.
60.
Oh, 6. I don't know why I keep saying 50. Okay, yeah, it's half.
Someone has their shoes
Okay.
off.
So again, the work done is 150 joules. The power generated is only 30 watts. Okay, very low power rating, just so you know, relatively speaking. Any questions on work and power? That's really all we went into, not much more.
So easy.
We did the work kinetic energy theorem. I'm not going to put that on the last part, I'll tell you now. Okay, it might be something for the final exam, but we'll get back to that when we get to it.
Wait,
No, the hardest part.
The work kinetic energy theorem.
Motion. Because we haven't done that. So
I'm really not
everything
gonna-
else we've done, like,
Recently, yeah.
yeah.
All right, next one.
Yeah, that's gonna just be so annoying.
everything else is like. What is it?
Yeah, I'm probably just gonna omit that.
Yeah. Wait, how many do we get to omit? Only 2?
3.
Hey.
Mr. Hall's not letting me study a lot tonight, so
Yeah.
I'm gonna cross that one off the list.
Mr. Al looks like he's gonna blow chunks
If
off.
that's all the time, then I'm just not
He's
gonna
about
study
to
it.
projectile motion some throw up.
Ew.
An object is fired
We measure Plato of his.
from a, from a cliff of 100 meters with an initial velocity
Gabby's
Of-
clear hiccups.
20 meters per second. Determine its velocity when it is A at 40 meters above the ground, B at ground level. Before we begin this problem, let's think logically. Which answer will be greater? Is the object going to have more speed at the ground or above the ground at 40 meters?
Above, at the ground. At the ground.
Why, Erica?
Because he doesn't have. It should be above the ground. What do you mean?
Emmett?
Isn't it just being fired at the ground, like from the ground? Or is it talking about when it hits the ground?
So I want to know, what is the velocity when it's 40 meters above the ground, and then when it's about to hit the ground?
When it hits the ground, it's going to be greater because it's right before impact, and that's the impact velocity, and that's the quickest.
Exactly. An object picks up velocity as it falls, right? Drop your pen. It's going to pick up velocity as it falls. So when it's about to hit the ground, it's going to have more velocity. So part B will be greater than part A. Let's draw ourselves a diagram to show this, and we'll look at our energies at each level.
Wait, why is it going to be greater ground level again? I just forgot.
Because an object picks up velocity as it continues to fall until it reaches what's called terminal velocity.
Oh, that makes
Okay.
sense.
So we want to know, again, this height of the cliff is 100 meters. We want to know the velocity here and here. Okay, we want the velocity at part A and part B. At part A, the object still has height. It's got a height of 40 meters. But at part B, it has no height. Okay, it is at ground level. Tell me, please, what types of energy does the object have when it's at the cliff? As it's being fired, what kinds, Kareem, of energy does it have? And? Good. Potential, why?
Because of the height, and kinetic because it's moving.
And because of the good, because it's moving with some initial velocity. Those two things, the height and the initial velocity. Now, at point A, what types of energy does the object have at point A? Helen?
It still has potential, I feel like.
Good. They're going to be different, but it still has potential and kinetic. Because think about it. At point A, it still has height. The height is 40 meters. And it's moving, so it's got to have kinetic. Chelsea, when it's about to hit the ground, what happens to one of those energies?
One cancels off.
Which one?
P.
Good, because it's no longer has height. So here it's got kinetic energy, but it's got no potential energy. So this is like a two-part problem. Let's do part A first, and look at our equation, and then redo it and do part B. So, for part A, initially we have potential energy and kinetic energy. And then when it gets to 40 meters, we still have potential energy and kinetic energy. Formulas, without looking at your formula sheet. Anybody got these ones for me? Nicole?
PE is mgy and KE is 1/2 mv squared.
Good. So again, you don't need to memorize it, but see how inherently you do end up memorizing it? Okay, just because you use it so much and you practice. Nicole, follow-up question. What happens next to make this easier on me?
The masses cancel out?
Good. Whenever there's a variable in every single term, it always drops off. It's like dividing the whole equation by m and it's gone. How come you knew that's going to happen in the beginning of this problem? Yeah, there's no mass given. So there's a good chance it's going to drop off. What are we finding? We're finding VF. Let's move GYF over. Okay, so I'm taking this quantity and subtracting it over. Then I can multiply by 2 and take the square root. Again, subtract this over, because there's a positive sign in the front here. Get rid of the 1/2 by multiplying by 2. Then get rid of the square by taking the square root. So put a 2 in the front. God bless you. And then take the square root of the whole thing.
So why did you put a 2 in the front?
Because I need to get rid of this 1/2.
Oh.
We're solving for VF squared, and there's really a 1/2 here. So we multiply by 2 on this entire side. The entire thing we multiply by 2, and then we take the square root.
What are you getting to find out?
I have no idea. Do 9.81 times 100 plus 1/2 times 20 squared minus 9.81 times 40 all times 2 square rooted. Now, I don't even want to do part B. I don't have to do part B, really. What did we say the only difference was, and Chelsea, you answered this question, between part A and B in energy terms? What's missing in part B? Potential energy. Again, take a look right here, please, in the diagram. There's only kinetic energy. So just do this. Ready? Cancel that out. It's not there anymore. Put a big line through here for part B, and that drops off. So there's no GYF. So just go like this. And that's your answer for part B. Do you see how important it is to solve generically now? See how much time you just saved on your test? There's no need to do it again. Just write it's the same answer without the GYF.
Wait, how do you know if it's on the PDF?
Because look, Sibylla, when it hits the ground, as it's about to hit the ground, is there any height? So what would happen to YF? Y is the height, isn't it? Wouldn't that just be 0? So this term right here would become 0, which is why this is 0, which is why this is really 0 for part B.
34.37.
Any questions on this problem? Any questions? I know we're all tired. It's been a long day. All right, the last thing I want to do is just look at the formula sheet real quick so we're all clear as to what equations are used for what and how to expect them. So I'm going to just quickly, hold on, let me just import it.